Good day, students. Welcome to Quarter 4, Week 1 lesson in Statistics and Probability. Our topic will be about testing hypotheses. Let us be guided by the following objective. First, you should be able to define and illustrate the null hypothesis and alternative hypothesis, level of significance, rejection region, and the types of error in hypothesis testing. Second, identify the rejection and non-rejection regions and the critical values. Third, differentiate type 1 and type 2 errors in claims and decisions. Fourth, define the parameters used in statistical analysis. And last, to identify the parameter to be tested in a real-life problem. According to a survey, the average daily usage of social media worldwide of a global internet users amounts to 142 minutes per day. So this is according to what Sophia had researched. To verify, Sophia conducted her own survey among her friends to find out if their time spent on social media is significantly higher than the global survey. So ngayon, so from this problem, we can see that there is an existing claim conducted worldwide about the number of time internet users use social media, and that's actually 142 minutes per day. So based from this previous claim, we want to have our own hypothesis, and that is based from Sophia. She wants to find out if her friends are exceeding this specific amount of time. So this is actually the individual data obtained from Sophia's friend, and if we're going to compute for the average minutes of this, finding the sum and divide by 10, the mean will be actually 152 minutes per day. Let's have some questions. Number 1, what statistical data is or are needed to prove which of Sophia's claim is accepted or rejected? So what we used is the average time spent. Average time spent on social media. Second, what is the average daily usage of social media of her friends? So her friends spent an average of 152 minutes per day, while the global internet user has 142. So compare it with the previous average usage. So if we compare, the daily average usage of social media of her friend is actually higher than that of the obtained average from the global users. Which of the two claims could probably be true, or why? If we're going to examine, we can consider the previous claim, or the 142 minutes per day could probably be more valid and reliable. One reason is that it is conducted in with wider respondents because it was conducted globally. Second, if proper sampling was made, you were able to get respondents from different groups. Unlike Sophia's respondents, it's coming from her friends. So probably they'll be sharing the same characteristics. So kung medyo addicted or medyo mahilig mag social media si Sophia, probably her friends or the people around her or that surrounds her could probably having the same characteristics. If Sophia computed the average daily internet usage of her friends to be higher than the global survey, do you think it would be significantly higher? So it is higher figuratively, but the question is, would it be significantly higher? Would that 10 minutes significant to say that it is really higher than? Kung talagang naiba siya. Let's answer that later on. What is your idea of an average value of being significantly higher than the global average value? What is this significantly higher? So I hope we get to answer this one later. What do you think is the difference between simple comparison of data and hypothesis testing? It's very literal. When you say simple comparison, you just merely look at the figure, it's 152 greater than 142, so we probably conclude it's higher. So if we say hypothesis testing, it undergoes processes, statistical processes, that will verify if these values, if this difference in figures are significant. That's what we're going to discuss for this week. When you say hypothesis, it is a proposed explanation. It is an assertion. It is an assumption about a population parameter or about the distribution of a random variable. So, yun yung sinasabi nating hypothesis. It is someone that you believe in, you thought that could be true, no? Possible na mangyari based sa yung population or based sa iyong sample, no? When you say hypothesis testing, it is a process or a statistical method of verifying your hypothesis. No, we are going to identify if the hypothesis could be accepted, it could be rejected or failed to reject. No, we use that in making decisions in statistics, most especially in experimental data. We have two types of hypotheses that we need to have when we are testing, no, the hypotheses. The first is the null hypothesis and the second is the alternative hypothesis. When you say null hypothesis, it is the initial claim based on previous analysis. No? So when you say null hypothesis, it is the fact. No? Just like in the previous problem, it pertains to the daily average usage social media of our friend is the same as the global average usage. So we made use of a factual comparison. No, hindi muna tayo magde-deviate from the previous claim. If it's 142 minutes per day, then let it be. If the brain size of male high school student is 120, so let it be. If the lifespan of the Filipino people is 160, then let it be. That is what null hypothesis is. Most of the time, it made use of equality symbol. We don't compare yet. That's what null hypothesis is. This will be our basis. This will be our fact. Now, on the other hand, when you say alternative hypothesis, it is contrary to our null hypothesis. This is actually what we assert. This is actually what we thought, what we believe in, what we thought could probably do, that will deviate from the null hypothesis. So this time, you will not going to use equality symbol. Probably, pwede mo lang sabihin na, no, it's not equal, it's higher than. No, the brain size of male high school students this generation is a bit smaller. You can say that the lifespan of Filipino people in this decade is a bit smaller in terms of age. So that's the time you made use of inequality symbol. That is contrary to the null hypothesis. So in Sophia's problem, no, the null hypothesis was about it's equal to 142 minutes per day, but you want to find out if the average daily usage of social media of her friend is significantly higher. So probably made use of greater than symbol. So if the HO made use of equality symbol, the HA made use of 3. It's probably, you could say, mas mataas, greater than, mas mababa, less than, probably mababa or mataas, meaning to say not equal to. So these are only the symbols that's related to null and alternative hypotheses. Let's have some example. Let's state the null and alternative hypothesis. A medical trial is conducted to test whether a new medicine reduces uric acid by 50% or not. Now, there is a medical trial that's conducted and we want to find out if it is effective in reducing the uric acid, no, by, let's say, 50%. So, in your null hypothesis, you will just state first that nothing happens. That the medical trial cannot reduce the uric acid by 50%. That's only the fact one. Now, in alternative hypothesis, we want to say that it is effective. That the medical trial is effective, therefore, the medical trial can reduce uric acid by 50%. Okay, I hope this one is clear to you. So, it cannot reduce, meaning to say it remains the same, equal. The medical trial can reduce uric acid by 50%, it means less than. That's found to be effective. So, yun yung pagkakaiba nila. Second, we want to test whether the general average of student in mathematics is different from 80%. So, let's state first the null hypothesis. Let's state first the null hypothesis that the general average of student in mathematics is 80%. No, without any comparison na yet. And that's the time we include our assertion based on the statement that the general average of the student in mathematics is different from 80%. It could probably, when you say different from 80%, it's not equal to 80%. It could probably be higher or lower than that. But for the null hypothesis, we say that the average is equal to 80%. So I hope this one is clear to you. The use of symbol. For the first one, by 50%, the average is less than 50%. In terms of its effectiveness, no? Third example, we want to test whether the mean height of grade 8 student is 58 inches. So that's actually our null hypothesis. No. So to have it a factual, so you state it's equal to 58 inches. For the null hypothesis, the mean height of grade 8 student is not 58 inches. Meaning to say it could probably lower or it could be probably greater than 58 inches. Fourth, we want to test if LPIHS students take more than 4 years to graduate from high school on the average. So you don't say take more than, you state first that the LPIHS students take 4 years to graduate from high school. So the average time will be 4 years. Now on your alternative hypothesis, you state that students take more than, so that the average time is more than 4 years. So that's what we do with the null and alternative hypothesis. Last example, we want to test if it takes less than 60 minutes to answer the quarterly test in calculus. So you only say that it takes 60 minutes to answer the quarterly test in calculus for your null hypothesis. And for the alternative hypothesis, you state that it will take less than 60 minutes. Yeah. So I hope the null alternative and alternative hypotheses are now clear to you. Let's proceed with other terminologies. Next will be the level of significance. Level of significance denoted by the alpha refer to the degree of significance in which we accept or reject the null hypothesis. Actually, the level of significance is the degree of significance in which we reject the null hypothesis. No? So if we have the level of significance, let's say 5%, that's the degree in which the null hypothesis will be rejected. The remaining 95%, in researches, it is said to be the confidence level, which was not mentioned in this lesson, but I have to, kasi this most of the time this appears on research. So in researches, the confidence level are always mentioned. For example, the confidence level is 95%. So it only means that it is the percentage in which the null hypothesis will be not rejected. And the remaining 5% of that 100%, when the 95 is a confidence level, that will be the level of significance, which will be the rejection region for the null hypothesis. So if, let's say for example, indifferent scenario on our hypothesis, if our HA, if our claim says that the mean is less than the previous mean, so that's a left-tailed, that is our alpha, and that is our rejection region for HO. If you says that in HA or in your claim that this mean is really greater than the previous mean from the population mean, no? So you are now on a right-tailed test. When this alpha, the shaded region, is again the rejection region for HO. And when it's not equal to, you have to divide your alpha into 2, so it will be distributed both on left and right. So that's how we do the significance level. So if we know that we're going to use less than or equal into HA, that's one-tailed test. If we use not equal to, that's two-tailed test probably. So let's identify if we're going to use one-tailed test or two-tailed test. The mean height of grade 12 student is less than 66 minutes. So our HA here made use of less than. So this is, for our HA, we focus on HA. That's less than 66 inches. So this is actually one-tailed. Yeah. That's for our HA. The standard deviation of their height is not equal to 5 inches. So it made use of not equal to. So this is two-tailed. Number 3, male grade 7 and grade 12 students differ. So it's just the same as not equal or different. So this is also two-tailed. The proportion of senior male students' height is significantly higher. So higher means greater than. This is only one-tailed test. And then the average grade of grade 11 student in statistics is lower than their average. So meaning to say less than one-tailed test. So I hope you get to see how the alternative hypothesis can identify if it's a one-tailed test and two-tailed test, and it will also help to identify our alpha, which is also our rejection region for HO. So in the problem of Sophia, if this would be our research, let's say that Sophia made use of 95% confidence level. On the other hand, that also means a 5% level of significance in proving that the average daily usage of social media for friends is the same as the global average usage, which is 142 minutes per day. Now let's try to illustrate those terminologies from hypothesis to level of significance so that we can identify the rejection region. When you say the rejection region, this is the critical region that is set of all values of the test statistics that causes us to reject the null hypothesis. So again, that is our alpha. Okay, so we know that this is our alpha, and that alpha is our rejection region for HO. Okay, and this is the white one will be our non-rejection region for HO. We could also focus to HA, but it will mean the other way around. So if we reject, if this is the rejection region for HO, this will be the non-rejection region for HA. On the other hand, if this one is the rejection region for HO, this is the non-rejection region for HO, this is the rejection region for HA. Rejection region for HA. Because they are contrary to one another. So if you reject HO, you fail to reject the HA. So this critical value, you can identify this using the tables. The distribution table. It could be the T table, the Z table. It depends on what needs to be used. Let's say it's a problem of Sophia, no? We may from the T table, from the T values, since ang respondent ni Sophia is 10, so our freedom of degree of freedom will be subtract 1 from the sample size. So that will be 10 minus 1, that's 9. So we use this 9 here. And then since it's a one-tailed test, so we use the significant level, one-tailed test, with a 5% level of significance. So crossover natin. So our critical value will be 1.833. That's the one to be put in our critical value. So that's our critical value. This sets the boundaries for our rejection region and our non-rejection region. Let's now compute for the computed value to find out if the value falls under rejection or non-rejection region. So remember, from the problem Sophia, we can make use of the formula for computed p-value and substitute the value. So the sample mean will be 152. The population mean is 142. The given standard deviation from the sample, from the 10th sample when computed is 19.855. And then square root of sample size, it's 10. So when we calculate, it's 1.593. So that's our computed p-value, which is very important to compare from our illustrated rejection region. So yung ginawa natin kanina, no, this is the 1.833 computed critical value, and this is what we have computed, 1.593. If we're going to plot it in our distribution, that is under the non-rejection region. Now, dito sa kulay puting ito. So, we could say now that the null hypothesis will not be rejected. And on the other hand, we will reject the HA. Okay? So, how do we conclude this one? So, we are in the non-rejection region, meaning to say we will fail to reject the null hypothesis. Okay? So, what are we are now going to state or accept actually our null hypothesis that the mean average is still equal to 142 minutes per day. It only means that even though we have computed 152 minutes per day for the 10 sample friends of Sophia, it's still not different from 142 minutes per day. That's according to what we have studied. Now, pasok pa rin siya sa 142. After computing the errors on this research computed by the t-value, computed t-value formula, yung 10 minutes na yon, it doesn't matter. It won't really deviate from the global research conducted, no, dun sa ginawang simple research ni Sophia. So this is now what we mean by significantly higher. No? If we're going to make a simple comparison between two figures like 142 and 152, we could say that the figures are far from each other by 10. But if we're going to compute it statistically following these steps, we could say that 152 is not that much different from 142. Because after computing error, they are found to be on the range of the average time spent on social media. No, ganun kasi yun eh. Pwede kasing hindi siya magsasakto sa 142, but considering the errors, katulad ng bias na pagkuha ng sample kasi puro kaibigan lang niya, so talaga magbabago yun. So, considering that error, na nakocompute na rin naman doon sa computed t-value, hindi siya lalagpas doon. Meron tayong range na tinatawag, or interval, confidence interval. Let's have this one example. The critical t-value from the table is negative 1.671, negative 1.6. And this is our critical value, 671. So this is our rejection region. And then the computed t-value is negative 2.45. Ito siya. So it falls under the rejection region. Ayan. Next, the critical t-value is positive 1.725, 1.725, and the computed, this is our rejection region, and the computed is positive 2.14. So it is also still under rejection region. Next, the critical t-value from the table is positive 1.311, 1.311, and positive 1.311. So this is our rejection region for HO. And the computed value is negative 1.134, negative 1.1. So dito siya. So this is under non-rejection region. So you will not reject HO. Yeah. So we have now this type 1 and type 2 errors in making decisions. Maybe we have seen already where the critical value, where the competitive value falls on the distribution. No, pwede na ilagay mo siya dun sa rejection, dun sa shaded part, or dun sa not shaded, which is the non-rejection region. But then, you also still have to state whether you will accept or reject it. And unfortunately, or accidentally, siguro hindi mo siya na-state ng maayos, so there are two possible errors that will be committed. For example, if the null hypothesis is true siya, but you reject it, that's called the type 1 error. On the other hand, if the null hypothesis is false, and then you accept it, or you fail to reject the null hypothesis when it is false, that's the type 2 error. Now, what do we mean by that? Okay. So we have two things to do when we have two things to conclude when we are having the hypothesis testing. That is identifying the truth about the population. So nag-graph tayo, no? So dalawa yung pwedeng mangyari doon. It's either HO is true, yan, HO is true, or HO is false. No? Ibig sabihin kasi na HO is false, the HA is true. Kaya lang nakakalito yung table pag HO, HA. So we focus on HO. When the HO is true and when the HO is false. So dalawa yan. And then, after identifying the truth about this one, gagawa ka na ngayon ng decision mo. It could probably you reject the HO and accept the HO. Okay. If you found out that the HO is true and you reject the HO, that's called the type 1 error. Okay? Yun yung tinatawag natin type 1 error. But when the HO is false and you reject it, that's called a correct decision. False siya, so you reject it. No? Yan. On the other hand, if the HO is true, tapos inaccept mo si HO or fail to reject, that's a correct decision. But when the HO is false and you accept the HO, that's a type 2 error. False siya, pero inaccept mo siya, that's a type 2 error. There would be a lot of consequences on researchers if you do that. Let's have some example, katulad nito. A quality control expert wants to test the null hypothesis that the imported solar panel is an effective source of energy. So the null hypothesis in this problem is effective source, yung ating solar panel. Therefore, ang ating HA is not effective. Contrary no? Yan. Pag sinabi natin, what would be the consequence of a type 1 error? What will be the consequences of a type 1 error? You are rejecting the null hypothesis. No, eto, nire-reject mo si null hypothesis. Reject when true. Reject when the HO is true. So, ibig sabihin, hanapin natin dyan, they do not conclude that the solar panel is effective when it is not actually effective. Tama naman to, correct decision to. They conclude that the solar panel is effective when it's actually effective. This is a correct conclusion kasi conclude mo siya that it's effective when it's actually effective. They do not conclude that the solar panel is effective when it is actually effective. So, eto yun. No, nireject mo siya, you did not conclude, no, nireject mo siya, you did not conclude that it's effective when it's actually effective. That's a type 1 error. Medyo nakakalito siya, so please bear with this. Type 2 error naman. So, ibig sabihin naman, sa type 2 error, no, inaccept naman siya, accept when false. No? False siya pero inaccept. So, ano ibig sabihin nun? So, that's the fourth one. They conclude that the solar panel is effective when it is not actually effective. So, yun yung type 2 error natin. Yan. So, I hope these errors are clear to you. Now, let's just have some review on parameters and statistics. This was included on our lesson dun sa lesson number 1, Introduction to Statistics. When you say parameter in statistics are important components of any statistical analysis. In simple words, a parameter is any numerical quantity. Any numerical quantity. Siya. It could be mean, standard deviation, yan. Standard deviation, variance, proportion, yan. So kahit ano siya, that characterizes the given population. Basta about sa population, kahit anong measurement na gawin nyo, that's called parameter. So it's called population mean, population standard deviation, population variance, population proportion. On the other hand, when you say statistic, it is a numerical measure that is calculated from the sample. Sa sample naman siya. So, ang tawag naman sa kanya, sample mean, sample standard deviation. Most of the time, ang nakukuha natin ay ating statistic kasi we only use samples. We cannot manage or organize the whole population. Kaya lagi tayo nasa sample. Statistic lang ang laging ginagamit. When it comes to the symbol, eto na, magiging malino na sa inyo. When you see the X bar, the X bar, that's the sample mean. The S squared, that's the sample sample variance. The S, that's the sample standard deviation. The P hat, the sample proportion. Lahat ng alphanumeric, that's called sample. That's coming from the sample. When you see Greek letters like the mu, sigma squared, sigma, and the phi, so that's the parametric na. That's the measures obtained from the population. So it is now called the population mean, the mu, population variance, the sigma squared, population standard dev, yung sigma, at population proportion naman sa phi. So yun yung, pag naka-encounter kayo yan, so you know already where it was obtained. Dati kasi interchangeably, kung hindi pa yan malino sa inyo, you can use them interchangeably. Okay. So for our assessment, please answer the following, screenshot and then answer. So, yan, screenshot, set A, part A, part B, part C, and part D. So I hope everything is clear to you now about hypothesis testing. So I have already given you a background of how to do testing hypothesis or hypothesis testing. Next week, now we will be focusing on more on computing critical values. Now, with different scenario. May mga iba't iba kasing scenario tayo na we cannot directly compute for computed p-value na kasing dali nung kaninang example natin kay Sophia. So I hope everything is clear to you now when it comes to testing hypothesis. See you again next week for another meaningful discussion. Goodbye!